Hello students, in this video we will discuss the additional question bank questions of the chapter on permutation and combination. I have 3 questions here. First question is, there are 6 routes for a journey from station A to B. In how many ways you may go from A to B and return if for returning you make choice of any of the routes. Now, A and B, these are 2 stations. Now, a person may go 6 routes from A to B. From A to B, we have 6 routes. And for returning, you may choose any of the routes. Means for coming back also we have 6 routes. For going we have 6 routes, and for returning we have 6 routes. So these 2 are multiplied because first activity is done and second activity is done. Second activity is done after happening of first activity. So we are multiplying it. So the total number of routes will be 6 into 6, that is 36. So here option C is the correct answer. Now we see the question number 2. Question number 2 says, as per question number 1, if you decided to take same route, you may do it in dash number of ways. Now, person goes from A to B and 6 routes are there. For returning, the question says that you decided to take same route. Means we have only one route while coming back. That is, for coming back we have one route. So this activity can be done in 6 into 1, that is 6 number of ways. So we have here answer A, which is the correct answer. Now in question number 3, as per question number 1, if you decided not to take the same route, you may do it in number of ways. Now for going from A to B, we have 6 routes, and for coming, you have decided not to take the same route. Means one route is eliminated. You cannot do the journey by that route. So for returning, we have 5 routes. So the number of ways will be 6 into 5, that is 30. So here option D is the correct answer. Question number 4. How many telephone connections may be allotted with 8 digits from the numbers 0, 1, 2 and so on up to 9? Options are 10 raised to the power 8, factorial 10, 10C8, 10P8. See, we want to know the number of connections of 8 digits. 1, 2, 3, 4, 5, 6, 7, 8. These 8 places are to be filled from the numbers, from the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are 10 digits, 10 numbers. So first place can be filled with 10 number of these. 0 can come here because a telephone connection can have 0 at first place. Similarly, second place can also be filled with 10 number of ways because numbers can be repeated in a telephone connection number. Similarly, third place can be filled by 10 number of ways. Fourth place can be filled by 10 number of ways. Fifth can be by 10 number of ways. Sixth can be 10 number of ways. Seventh can be by 10 number of ways. And eighth place can be filled by 10 number of ways. 10 into 10 into 10 into 10 into 10 into 10. This is up to 8. So this is 10 raised to the power 8. So the number of connections which can be allotted of 8 digits are 10 raised to the power 8. Option A is correct. Here we have assumed that the telephone number can have 0 at its first place. Question number 5. In how many different ways 3 rings of a lock can combine when each ring has digits 0, 1, 2, 3, etc. up to 9, leading to unsuccessful events. Options are 999, 10 raised to the power 3, factorial 10, 997. See, the log is of this type, like we have in many briefcases and attaches. It has 3 rings. Here, this place can be filled by 10 number of ways. These are 10 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are 10 digits. So this place can be filled by 10 number of ways. Again, this can be filled by 10 number of ways. And again, this can be filled by 10 number of ways. So the number of ways, total number of ways will be 10 raised to the power 3, that is 1000. Now we want that it should number of ways which are unsuccessful events, because now we know that by one way this lock will be open, that will be a successful event, otherwise it will be unsuccessful. By any of the numbers, by any of the combination, by one way only it will be open. So for unsuccessful events the number of ways will be 999, because that one successful event we are to subtract from 1000. So number of ways leading to unsuccessful events that is by which the lock will not be opened will be equal to 1000 minus 1, that is 999. This one is which event, in which, by which combination the lock will be open. So here we find that option A is correct, 999. Question number 6. A dealer provides Maruti car and van in 2 body patterns and 5 different colors. How many choices are open to you? Options are 2, 7, 20 and 10. See, one is Maruti car and second is van. Now Maruti car is available in 2 body patterns. So 2 body patterns. Now each body pattern is having 5 colors. So 2 into 5, that is 10 types, 10 choices are available for Maruti car. Now we see for van. Again we find it is having 2 body patterns and 5 colors. Each is having 5 colors. So 2 into 5, that is equal to 10. So 10 choices are available for van. So total number of choices will be 10 plus 10. Total number of choices is equal to 10 plus 10, that is equal to 20. So here option C is the correct answer. Question number 7. 3 persons go into a railway carriage having 8 seats. In how many ways they may occupy the seats? See, 8 seats are there. 1, 2, 3, 4, 5, 6, 7, 8. 8 places are to be filled by 3 persons, by 3 objects. This can be done by 8p3 ways, which is equal to factorial 8 upon factorial 8 minus 3, that is 5. We can write it 8 into 7 into 6 into factorial 5 upon factorial 5. Factorial 5 and factorial 5 are cancelled, which is 8 into 7 into 6. We can understand it by different way also. There are 8 seats available. 3 persons are to occupy them. Now first person has 8 choices. So first person has 8 choices, 8 into, now one place is occupied. So second person, whenever he will go, he can have 7 number of choices. So second place can be filled by 7 number of ways, and similarly for Third person, he has 6 choices, so it is 6. First activity is done, then the second activity is done, and then the third activity is done. That is why they are multiplied. So this comes as 8 into 7 into 6, which is same as 8p3. So here option A is the correct answer. Question number 8. Find how many 5-letter words can be formed out of the word logarithms. Word may not convey any meaning. Options are 10p5, 10c5, 9c4 and none. See, logarithm has letters L, O, G, A, R, I, T, H, M, S. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 letters. Now we want to make word of 5 letters. So 1, 2, 3, 4, 5. These 5 places are to be filled from these 10 letters. At first place any of the letter can come. So this can be filled by 10 number of ways. Any of the letters can come at this place. One has come, suppose O has come, then remaining 9 can come here. So this can be filled by 9 number of ways. Similarly, this by 8, this by 7 and this by 6 number of ways. So total number of ways will be 10 into 9 into 8 into 7 into 6. This is our answer. Now, if we see option A, it is 10p5. When we simplify this, we know that npr is equal to factorial n upon factorial n minus r. So this will be equal to factorial 10 upon factorial 10 minus 5, that is factorial 10 upon factorial 5. Factorial 10 can be written 10 into 9 into 8 into 7 into 6 into factorial 5 upon factorial 5. Factorial 5 and factorial 5 are cancelled. So this is same as this. So here our option A is correct. By 10p5 number of ways, 5-letter words can be formed from the word using letters of logarithm, where word may not be conveying any meaning. Question number 9. How many 4-digit numbers greater than 7,000 can be formed out of the digits 3, 5, 7, 8, 9? Options are 24, 48, 72 or 50. See, 4-digit numbers are to be made. 1, 2, 3, 4. Means these 4 places are to be filled. Now the digits available are 3, 5, 7, 8, 9. Number should be greater than 7,000. Now for number to be greater than 7,000, this place, first place can have either 7 or 8 or 9. These 3 digits will be there at first place because the number is more than 7,000. So first place can be filled by 3 number of ways. Now 1 we have used. Suppose 7 we have used. Then we have 4 choices for this place, second place. So this place can be filled by 4 number of ways. Now 2 we have used. Suppose 7 we have used and 5 we have used. So now we will be having 3 choices, 1, 2 and 3. So this place can be filled by 3 number of ways, and this place, last place, can be filled by 2 number of ways. So total number of ways will be 3 into 4 into 3 into 2. We are multiplying because the first activity is done, then the second activity is done, then the third activity is done, then the fourth activity is done. If it is done in this manner, then we are to multiply. So the total number of ways will be 3 into 4 into 3 into 2, which is 3 into 4, 12. 12 into 3 is 36. 36 into 2 is 72. So here we find option C is the correct answer. Question number 10. In how many ways 5 Sanskrit, 3 English and 3 Hindi books can be arranged keeping the books of same language together? We have 5 Sanskrit books. Now Sanskrit books themselves, since they are 5, they can be arranged in factorial 5 number of ways. So Sanskrit books can be arranged in factorial 5 number of ways. Now we have 3 English books. So English books themselves can be arranged in factorial 3 number of ways. So English books can be arranged in factorial 3 number of ways. We have 3 Hindi books. So Hindi books can be arranged in factorial 3 number of ways. Now we have 3 categories. Suppose these 3 places are there. Here Sanskrit books are there. Here English books are there. Here Hindi books are there. Now Hindi books can come at this place also. English is here, Sanskrit is here. Likewise, Hindi may come here also. Here Sanskrit can come and here English may come. So these 3 categories themselves can be arranged in factorial 3 number of ways. So these 3 types of books, 3 languages of books can be arranged in factorial 3 number of ways, because they are of 3 types. So total number of ways will be, therefore required number of ways will be factorial 5 into factorial 3 into factorial 3 into factorial 3. We are multiplying because first activity is done, then the second activity is done, and likewise the other activities are done. And if this happens, we are to use the multiplication formula. So this is our required number of ways, and hence our option A is the correct answer here.